Okay, we're good? Sit down! Why, hello! So here's where we are in the unit. We've already done area, we've done volume of revolution. For the last couple days we've been talking about volumes and the cross sections and all the things. So somewhere in the unit, guys, find a place to jot this down. I want to make sure we're on the same page. Yesterday was about making your life easy, and for many of you, I think that was mission accomplished. So we've got some function up here, f of x, we've got some function over here, g of x. This guy here is my base. And rather than asking the question, what happens when you take your base and you spin around the axis of rotation, or axis of revolution, the conversation was, what happens when you start slicing it up? What happens if your solid has this as the base, and for example, you have squares? If you have square cross sections perpendicular to the x-axis. Take a second. I want to hear it and I want to see it. Your cross sections are perpendicular to the x-axis. I want to hear it and I want to see it. You're slicing this way, which means dx. Okay? Those are your slices. So when you're doing your slice, you're slicing this way. You're slicing, wow, three-dimensional. Now the hard part is, I can't envision necessarily the three-dimensional piece of it, but I know that there are squares, right? There's squares over here, there's squares over here, there's squares over here, and depending on where I am and where I am in the base, the slices are either really short or they're really long. Everybody okay? Mm-hmm. But regardless of that, how long are they? How do I determine the length of each of these slices for this particular base? How do I figure out the slice? Whether it's a long one or a short one, it's the same way. How do we do it? Oh my gosh, guys, how long? Top minus bottom, g of x minus f of x. That's that length. L of x is equal to g of x minus f of x. Well, what's the volume of the solid? The volume's going to have to involve doing an integral. What are we integrating? It's the square. Right? The length of the square is L. How far out of the board does the square come? L. How thick is the square? Dx. So the volume of your solid is going to be the integral of L squared dx from a starting point to an ending point. And those are going to be x equals something to x equals something. This is where we were the other day. Now, yesterday, the epiphany then came, well, what happens when we start looking at different slices? What if my slice is the right isosceles triangle? What if my slice is, if I said parallel to the y-axis? Parallel to the y-axis. Think about it. I want to hear it. I want to see it. Parallel to the y-axis. Carlos, you're going the wrong way. Here's the y-axis. Parallel to the y-axis. Still slicing this way, right? So, dx. So your base stays the same. The length of the slices stays the same. One thing changes with the right isosceles triangle. One thing only changes about the right isosceles triangle when you find the volume. This was the conversation yesterday. It's the constant that you multiply by. Look it up if you need to. What's the constant that you multiply by if it's the right isosceles triangle? It should be 1/2. So this is the setup if your slices are squares. If it's the right isosceles triangle, then your volume is going to be 1/2 the integral from x equals a place to x equals a place, L squared dx. Okay? What if we're slicing and the slice is parallel to the x-axis? I want to see it, I want to hear it. You're slicing parallel to the x-axis, we're going this way. What do we know? It's a dy integral. Delia, are you okay with the slice? Okay, semicircles. Slices are semicircles. right? You need to know the constant, or you're going to have to go through the geometry, which is where we spent the time yesterday. Look it up if you need to. For the semicircle, what's the constant that you multiply by? Wait, I heard partly. It's 1/8 pi. So this is for the semicircle. It's 1/8 pi, or pi over 8. And it's going to be that length squared, that same length. In this case, the length is the diameter. And what did I say? Parallel to the x-axis? So dy, we go from y equals place to y equals a place. Some starting point, some ending point. Equilateral triangle. Your slices are equilateral triangles. Square root of 3 over 2. Square root of 3 over 4, right? We went through the geometry on this again. It had to do with your length is L. All your angles have a measure of 60 degrees. The height of the equilateral triangle is square root of 3 over 2 times L. Okay, and the rectangle. Now, don't jump. Don't jump. I want you to stop and think about the rectangle. Rectangular slices parallel to the x-axis. Parallel to the x-axis. We're going this way, parallel to the x-axis, so dx or dy? Has to be dy. Parallel to the x-axis, and you have rectangles. Don't jump. Some of you are going to jump too quickly. And there's our first jumper. Jumped right off the bridge into the water beneath him. You're saying 1/3. Yesterday, the multiplicative constant was 1/3 because unlike a square, with a square, if you know how long the base is, do you know how long the height is?
Yes.
Why? Jesus, why? All sides are equal. All sides are congruent. Now, what about the equilateral triangle? Does that still work?
Yes.
All the sides are going to be congruent? Right isosceles triangle? All the sides are congruent? No, but the legs are going to be congruent. So here's L, here's L. The problem with the rectangle is that although I might tell you what the length is, you need to know what's going on with the height. Right? So what if I said, hey, my slices, they're coming this way, but the height of the rectangle is 5 times this part over here. Then the base is L. How far out of the board do I come?
5 times.
5 times L. So what happens to the volume? You've got L times 5L, so it's 5L squared. The 1/3 yesterday, Carlos, was because the height was 1/3 what the length was. Everybody okay? Knowing the slice, knowing the direction should make life better. So what I want to do is I want to stop talking, give you guys a little bit of practice. I want top of page 35, this one is calculator inactive. Problem number 1, we're going to give you 4 minutes. We'll see what you can do.
Pero
You've got to make sure you understand the base. This one's calculator inactive. What? I know. Yeah, Miss Villacorta, the tour that was supposed to be coming in got canceled, so feel free to get up and move around and intimidate teenagers. You don't have to, it's not an order, but.
Isn't the region R base? Region R as the base? Oh, let me. This is the solid L or equilateral triangle. like
Okay, we're graphing, right?
volume of the solid form. So if the V of the slash equals to the 2 to the 3 to the 4, that just gives you the volume of the solid. Integrals.
Alright, for all the folks watching at home, region R is the area enclosed by the function y equals x squared and the line y equals 4. Okay, y equals x squared, that's a parabola. We've got y equals 4. Okay. That's the base. From what I saw in the class, most folks were there. Keep going. Don't wait for me. Using region R as the base, a new solid is formed. Cross sections of the solid perpendicular to the x-axis. Which way? dx. I want you to understand it's the dx that's going to really make a difference here. So your slice, that's L. Already I know that my integral is going to be L squared dx. That's going to help guide your thinking. Jesus, what else do you know about these slices?
It's equilateral.
Cross sections are equilateral triangles. As soon as you realize that you've got the equilateral triangle slice, what do you know? All the sides are going to be equal, but in terms of the setup, what's the constant? Square root of 3 over 4. You know the constant right away. You don't have to go through all the business that we went through yesterday of the setup and figuring out the slice. You know it's going to be square root of 3 over 4 times L squared. Well, other things that we need, I need a starting point for my integration, and I need an ending point for the integration. How are we going to get those?
Intersection between x squared and y equals 4.
Right, I'm going to go from here over to here. I'm going to look at the intersection points. I bet most of you guys are able to just tell me,
-2 and 2.
right, we should be able to figure it out that those are x equals -2 and x equals 2. If you don't know it on sight, set the two equal to each other and solve it. If x squared is equal to 4, then x has to be plus or minus 2. So you're integrating from -2 to 2. The last question, how long is L? Juan, how long is L going to be? How do you figure out how long L is? Not Jose. Juan, see, this is why I get confused. Don't tell him, he doesn't need your help. How do you figure it out?
X squared minus y equals 4.
Wait, one more time? No, just him. He's got it. How long's L?
Y equals x squared minus 4.
Y equals x squared minus y equals 4. Is everybody okay with that?
Or is it the opposite way?
Or is it the opposite way? That's the question. How do you determine the length?
4 minus x.
It should be top minus bottom. It's always going to be top minus bottom. So L is 4 minus x squared. So your setup is going to be square root of 3 over 4. You integrate from -2 to 2. And then it's 4 minus x squared squared dx. How many guys honestly have that as your setup? We got one person, we get 2, we get 3, we get 4. Okay, in terms of the way points are going to get awarded, if you're able to find the integrand, 1 point, as soon as you're able to tell me the constant and the limits of integration, you're going to get another point. There's so much that comes from the setup that I wanted to spend some time here. Okay, take 2 more minutes, finish this off. I want you to integrate it. I want you to evaluate. I need you to simplify. Keep going. You get to integrate it. You get to evaluate. You get to simplify. Yeah, not right now. No. Need a little bit of a nudge in the right direction here. If you're going to find the antiderivative, the smart thing to do, I would expand this first, and then start using some power rule stuff. Keep going. here, 4 minus x squared. 16 minus 4x squared minus 4x squared x to the 4th. Right, nothing but a little bit of algebra 1. So we get square root of 3 over 4, an integral from negative 2 to positive 2 of x to the 4th minus 8x squared plus 16. And Beto, what do you have for your antiderivative here?
1/5 x to the 5th
Okay, 1/5 x to the 5th
minus 8/3
minus 8/3
x to the x cubed
x cubed
plus 16x.
plus 16x. Okay.
All that times square root of 3.
All that still gets multiplied by square root of 3 over 4. And then we're going to evaluate from negative 2 to 2. Naomi, finish it off for us. What are you going to do? Yeah, no, but you're a smart guy. You'll get caught
Big
up.
parentheses.
Yeah.
And then you plug in the 2.
You're going to plug in the 2.
Yeah.
And?
You plug it into the 2.
Right. Everywhere there's an x, you're going to plug into and then?
And you subtract it by the other side.
And then everywhere, what you get when you plug in the negative 2. Hopefully, like, that process is really comfortable. We're not going to worry about the simplification. What we know is it's square root of 3 over 4 times 1/5, 2 to the 5th, minus 8/3 times 2 cubed, plus 16 times 2, minus square root of 3 over 4, times 1/5, negative 2 to the 5th, minus 8/3, negative 2 cubed, plus 16 times negative 2. What's all that equal to? Let's assume this is free response part of the test. Please leave it. As soon as everything is a number, I don't know if you remember Miss Blakely, or I guess she had a different name back then. Free response, don't simplify, don't simplify, don't simplify. Just leave it and walk away. So the other points are going to come from, can you find the antiderivative? Of course we can. And do you know how to evaluate? That's what I care about. That's what the College Board's going to look like out of the free response. So with that said, let's see what you guys can do with this next one. Partner practice is top of page 36. Problem number 1. 4 minutes. Everything okay, Roberto?
Yeah.
Oh, you're getting like all fancy schmancy. I'm evil. Actually, maybe it's on the right page.
I am on the right page. Oh.
Come on now. If you need to go back to the notes to make sure you understand the slice, that's all right.
Yeah.
But if you didn't know it, I'm all about the base. About the base. No trouble. I have a 9-year-old. Megan Trainor is very much in our lives. And I know lots of the other ones, although the 9-year-olds are not allowed to listen. Great. Now, dear Mr. Dear future husband, stuff. Okay, seeing some good bases. Understanding the base is going to get you really far. Base of the solid is the region bounded by y equals the square root of x plus 1. Square root of x would look like this. Square root of x plus 1, we're going to shift one space to the left. Bounded by the x-axis. And bounded by the line x equals 3. Cross sections parallel to the x-axis or semicircles? Semicircles. Parallel to the x-axis. What do you know? dy. You know right away it's dy. So I would expect you to set it up right away and say, okay, it's an integral. And it's a dy integral. Why does that matter? That means that you know you're going from y equals a place to y equals a place. Slices are semicircles. The constant? The constant has to be pi over 8. Has to be pi over 8. The last question that you got to figure out is, how long are those slices? All those slices. They're all L. They're all found the same way. Top minus bottom, but look at the way the slices are going. This is why the direction matters. Right, it's not going to be top minus bottom, it's going to be right minus left. So right minus left. Which one's on the right?
3.
Okay. The guy on the right is going to be 3 minus which one's on the left? Square root of x plus 1. Anybody have a problem with that? You've got to talk about this guy here because you know it's a dy integral. Everything has to be in terms of y. So you're going to have to do a little bit of side work and say, okay, y is the square root of x plus 1. What is this in terms of x? And they're usually going to go with things that are algebraically not too bad to work with. So how do I solve this for x?
Square.
We're going to square both sides and then subtract. So x is y squared minus 1. Okay. On the right, you've got x equals 3. On the left, you've got x equals y squared minus 1. Just be careful. So it's 3 minus y squared minus 1. If you want to clean it up a little bit, sure. I think if you do that right, you're going to get 4 minus y squared. All right, let's finish it up. You've got 4 minus y squared is the length. You're going to square it. Last thing I need. What are the limits? Roberto, what are the limits going to be? You're going to start at y equals 0. Why?
Because it's wherever we'll find it.
You're not going to start over here at -1?
It's
Everything's a dy integral, which is why we focus on the dy or the dxness in the beginning. So this guy here is y equals 0. Where do you end? You slice, you slice, you slice, you slice, you slice. You stop at the intersection point. Where is that?
3.2.
Okay, right, that, we know the x value is 3. What's the y value? You go over here, square root of 3 plus 1 is 2. Okay. The hard part, the new stuff for us is the setup. You've got to understand the base. You've got to understand the direction and the type of slice that you're dealing with. And then from there, it's just all the good, comfortable calculus stuff that you guys are good at. Friends, we're okay? All right, one more with this, and then we're going to move over to the quiz corrections. See what you can do with problem number 2 on page 36. On this next one, all I want is the setup. We're not going to integrate it. And poor Jackie's not here. She kept asking, what about that question we didn't finish the other day? If we can do this one, you're fine. Make sure you understand the base.
You gotta find this one. Because you can't work with that.
like somebody's just breathing down your neck, watching every single thing that you write? No. I promise I didn't ask her to do that. I love the fact that she's doing it. Stay on him. Keep his hood off.
Can't stop.
The oval thing. You still with that?
The region inside the circle, defined by x squared plus y squared equals 36, is the base of a solid. Okey-dokey. Cross sections taken perpendicular to the x-axis. Okay. Equilateral triangles. Equilateral triangles. What's the constant? Wait, what's the constant? Square root of 3 over 4. Your constant's going to be square root of 3 over 4. Perpendicular to the x-axis. Has to be dx. Is that part feeling comfortable for everybody at this point? Okay, good. Well, it's a circle, and I know I've done a lot of bases that are circles this week. I would hope at this point, you know where the center is. The center is going to be 0, 0. And we know what the radius is. Uh-oh. What's the radius? Oh, God. Now I can tell the difference between Juan and Jose. You got the wrong answer. What's the radius? Not 36. The equation for a circle is x minus h squared plus y minus k squared equals r squared. The 36 represents r squared. So what's the radius? Square root of 36. 6.
That's what he
said. No, you said 8.
Yeah, he
No, he said 6.
And you said 6,
You said
which
not
is
36.
right.
But you said
And then he said 8. We'll play back the footage if necessary. Okay, let's get back to the base. Okay, you got the origin. Your radius is 6. 6 spaces to the right, 6 spaces up, 6 spaces to the left, 6 spaces down. Trained professional. There's the circle. Delia, which way are the slices going again? Perpendicular to the x-axis, so there's L. Now here's the thing. Do they all start and end in the same place? For all of your slices, whether you slice over here or you slice over here, are all the slices made the same?
Yes.
All of them. They're all going to be top minus bottom, and this is where we ran into a problem last class. They were like, but what's the top function and what's the bottom function? How are you ever going to figure it out? What's on top? Right, usually they're like, oh, there's an f of x and there's a g of x. What's on top here is the top part of the circle. What's on the bottom is the bottom part of the circle. Where are the equations though?
Yeah, solve the equation.
You know that x squared plus y squared is equal to 36. What we need to do is come up with the equation for the top piece and the equation for the bottom, and I saw a lot of you guys did this. If you know that x squared plus y squared is equal to 36, solve it for y. So y squared is 36 minus x squared. And what's y?
Square root.
Minus 8.
Okay, square root of 36 minus x squared. I like it, I don't love it. It's not going to work for us. You've got to include the positive and the negative. So what's the equation for the top part of the circle?
Positive.
It's the positive version. So up here, it's y equals the square root of 36 minus x squared. And the bottom
Negative.
is going to be the negative of the square root of 36 minus x squared. Take a minute, finish it off. You got all the pieces, you got to put them together.
From where to where?
So that's
Looking good. A lot of good stuff happening here. All right, volume obviously is going to involve an integral. What's the constant?
Square root over 4.
Square root of 3 over 4. Where do we start? Where do we end the integral? So you're going all the way from -6 over to x equals +6. You know that because you know the boundaries of the circle. And then it's always, always, always L squared. We went through that yesterday when we looked at the slice. The top curve is square root of 36 minus x squared. The bottom curve is the negative of square root of 36 minus x squared. Now you got to be careful. L is supposed to be the square root of 36 minus x squared minus the negative version. Minus the negative version means they don't cancel out. If this is just a setup question, this is 100% correct. You get your first point there. You're going to get the second point over there for the setup. If it's calculator active, you got one more point. Carlos and Evelyn, stay with me. We're good with the setups. If it's calculator active, you got one more point. You plug it into the calculator, out comes the point. But here's what happens on the multiple choice part of the test. And you know I'm evil, and the College Board folks are going to do this as well. This is a 100% right answer. There's nothing wrong with it. And they're not going to write it this way. They're going to hide it from you. I want to get some hands on this. What other things could I do? Could they do to hide this from you in the multiple choice? This is great. Kaylin, give me something.
well, I didn't write it like that. I wrote it as 2 square roots of 36 minus x squared.
Does that work? Square root of 36 minus x squared minus a negative, well, that's the same as saying add the two of them together. Square root of 36 minus x squared times square root of 36 minus x squared is 2 times the square root of 36 minus x squared squared dx from -6 to +6 square root of 3 over 4. Full points, it's great, it's right. Excellent. What else could they do to hide it from you? They're evil people, and I want to be one of them. I want to be that level of evil. What am I going to do to hide this from you in Tuesday's quiz? Square root the inside? How about square it? Thanks for the backup. 2 times the square root of 36 minus x squared squared. 2 times stuff, right? 2 times square root of stuff times 2 times the square root of stuff. What are you going to get? 2 square roots of stuff times 2 square roots of stuff is going to be 4. Square root of stuff times square root of stuff is going to be just the stuff, no square roots anymore. The square root and the square are going to be inverses of each other. You're still doing an integral. Let me erase this guy here. From -6 to 6, it's still dx, still square root of 3 over 4. Love it! What else? What are they? Shush. What else? I want to get some hands on this. What else? Think about how I'm going to hide this answer from you and make your life a little bit miserable. I keep hearing distribute. Oh, like distribute the 4 through the parentheses? Yeah. Agree. Something else.
can take out.
Take out.
Jesus, what can you do?
Take out the phone.
What do you mean? Why can you take out the 4?
Take the constant.
4 is a constant. You can take that 4 out in front of the integral. And so now they're going to say, oh, square root of 3 over 4 times 4 is square root of 3. And then you're going to go from negative 6 to 6. 36 minus x squared squared. How are folks feeling about this? We got it? There's one more thing that they're going to do.
Distribute the negative.
Yeah, I mean, you could distribute. There's one more thing. One more thing. What if they do this? What if there's an answer that says, you know what, we're just going to integrate from 0 to 6. 36 minus x squared dx.
1/2. Times 2.
If you only integrate from 0 to 6, you're talking then about this part?
Yeah.
Is anybody even going to think about picking that answer?
No. What?
Is there anything that they could do out here
1/2.
that would tell you that going from 0 to 6 could work for you?
I'm saying it's half.
Negative half.
It's half, so it's times 2.
If all you do is you go from 0 to 6, what you found is you found half of the volume. How do you get the whole volume?
It's 2.
You're going to double it. So what does the constant become now? It's going to have to be 2 times the square root of 3 because you're only integrating half of that volume. Are all the friends okay? All right. I knew that last one was going to be a push. All right, we got about 11 minutes left. What I want to do is give you guys some time to focus on corrections to the free response part of the quiz for Monday. The only homework assignment this weekend is to get all the corrections done for the quiz. Multiple choice for most of you guys went pretty well. Jesus, I know, I didn't forget. Okay, free response. I want to give you guys the first couple minutes. See what you can do. Now that we've gone deeper with volume, see what you can do. We're going to talk about part B in about 4 minutes. Jesus, now's your time.
Oh, we gotta go pee.
I'm gonna ask that too. Is that 'cause
Like he told me
If I was like, if I would have had that, let's have that Monday.
What if you have done?
Monday and
What if you what?
Wednesday.
Oh, no, you did. Your opportunity came in late.